Hello, this is Dr. Patrick Hanley at Hanley Innovations. Airfoil Digitizer is a software for converting airfoil picture files into really hard to find coordinates or ordinate files. The images can come from, journals, textbooks, the web, and then export them into a format that you can use in your CAD, CFD, or analysis program. To import the picture into Airfoil Digitizer, first click the File menu and then choose the Load Image option. Then you can load a file in any format. Here we are using a file that we found on the web. And then to digitize, just simply click the Digitize button. And this will capture all the points on the airfoil. Notice they are all outlined in blue. Another way to enter an image into Airfoil Digitizer is to find a program that produces an image, such as a CAD program, or even you can find images on the web, in this case, for example, and just right click and copy the image, and then you can go to Airfoil Digitizer, click on the File menu, and then use the option to paste the image into the software. Now when we click the Digitize button, we see there's a potential problem. Ideally, the airfoil should be the only image in the foreground. Fortunately, Airfoil Digitizer provides a workaround. The Click Image to Digitize option enables processing of cluttered images. For example, we can click the red color, which is the airfoil color, and then click that picture, and we see we can digitize the image. Let's consider two examples. And these images are taken from the UI/UC Airfoil database. Fortunately, along with the coordinates, we have provided a picture of the airfoil image. So what I want to do is to compare the captured image to the standard coordinates and see how well Airfoil Digitizer can convert these images into coordinate files. First, we start with the S1223. We see we can use the Click Image option to digitize it. And before we save it, let's look at the options menu on Airfoil Digitizer. In this box, we see that we have a number of options. The first set of options is the X distribution. We can use a linear distribution, we can use a cosine, and I did a second pass on the cosines distribution to get points very close to the leading edge and the trailing edge. The other option is to enter the airfoil name, so we'll know what airfoil we have in the data file. And of course, there's the X spacing option, which is the number of points in the chordwise direction. In this example, I export the airfoil data in the visual foil format so I can read it into multi-element airfoils. The next airfoil that I will import is the NACA 4412. This is a good example because multi-element airfoil has a NACA 4-digit generator. Then I can compare the picture or the image that I obtained from the UI/UC Airfoil database to the coordinates generated by the NACA tool. This is a good way to calibrate Airfoil Digitizer with respect to the number of exported points and the image size for a particular airfoil shape. Again, we export the NACA 4412 image using the visual foil format so it can be read into multi-element airfoils. An important thing to note is the number of points or spacing in the x direction. Even though a lot of points is a good thing, setting the number of spacings to about 60 produces very good images and very good correlation with analysis data. The next step is to load the two airfoils that we digitize into multi-element airfoils. Multi-element airfoils is a software package that can analyze, as its name implies, multiple airfoils. We can analyze starting with single isolated airfoils. We can also analyze configurations for flaps, slats, biplanes, triplanes, and any combination of airfoils. The software can accept upwards of 30 airfoils for a single analysis. Not very practical, but it can do that with 30 airfoils. So we load in the NACA 4412 and we look at the pressure coefficient. Next, we use the NACA 4-digit airfoil generator in multi-element airfoils, and we compare the coefficient from the Airfoil Digitizer to the coefficient produced with the NACA airfoil generator. And here we see that the pressure coefficient match pretty closely, noting that panel methods, we're using the panel methods option here in multi-element airfoils, are very sensitive to the airfoil coordinate data. Next, we compare the S1223 airfoil, and again we read it in with the visual foil format, and we would like to compare it to the data we also have from the UIUC airfoil database. So here we look at the graphs and look at the surface pressure coefficients for the digitized airfoil, and then we go to the airfoil data box again and select the UIUC airfoil database option. Here we can find the S1223 data that we have built in from the UIUC airfoil database, and then now we can just compare the pressure coefficients, and we see that we have a fairly good match of the pressure coefficient from the database, and also the pressure coefficient that we extract, the pressure coefficient from the airfoil that we extracted using the Airfoil Digitizer. Looking at the two sets of data, we see that the pressure coefficients from both the UIUC database and the NACA airfoil generator are in good agreement with the Airfoil Digitizer data files. Airfoil Digitizer is an excellent tool for obtaining hard-to-find airfoil ordinates from images. More information can be found at hanleyinnovations.com.